All right, let's learn some things. All right. So, OOJS. You asked for it, here it is. So,
I already have a question. why?
yes.
It's about that. Why are you so? I don't know. Like I asked about it, and then it seemed like you got really upset.
So, well, let's talk about what OOP is first, and then I'll hit on that. So, what is OOP?
Object oriented.
That's what like literally means. Like, what does it mean to be object oriented? Cheesy.
Because humans need things to be object to make sense. So they create this language that everything is an object.
Mm-hmm. So
To make more sense.
we'll say that OOP is literate versus functional programming, which is mathematical. That's exactly why OOP like became popular. Is that we talk about things pretty much how we see them: floor, desk, person has pen, that kind of stuff. Whereas functional programming, we're focusing a lot more on the mathematical relationships between things, which might be very different. Cool. What else do you know about OOP?
So instead of like functional programming where you define things in terms of functions,
Mm-hmm.
you define things in terms of objects, and all those objects have properties,
Yeah.
and those properties can be functions or whatever. So it's like, I guess it's like a different type of separation of concerns, almost. I don't know.
No, that's all accurate. So if I have a student class, they might have name and an age and other stuff. And then they also have these behaviors. So they might expose some of their state. So this is its state. This is me exposing it in a method. They might have other behaviors like learn, and learn takes in a lesson or something like that. Okay? So we're primarily dealing with, sometimes I call it nouns verbing each other. Okay, what else do you know about OO?
Well, I feel like having these nouns or objects maybe makes it easier to like collaborate with other people on code.
Mm-hmm. Yeah, because you can talk in like a very literate way rather than a mathematical way. Cool. Do we know the pillars of object-oriented programming? There are 4 of them. Cool. Look it up. 4 pillars of OOP. Let's take 5 minutes.
about love is a game to be played. Be torn and lost in the wilderness. To be lost and lonely and
Another minute.
what do you think about love is a way to be saved? Feel the warmth of another love. Just to be lost and lonely and I really don't know anymore. I really can't say. I really don't know anymore. I'm just that way. What do you think about love? It's a game to be played. To keep your own heart and head never loved. To be lost, lonely and cruel.
Oh, holy shit, if you're not going to do it. All right, shut up. Let's talk about it. So, what do we find out? Yep. Polymorphism? That's a big ass word. What's it mean?
Poly meaning many, and
Yep.
morphism meaning forms. So many forms.
Many forms. Beautiful. What does it like mean in human language for programming? All right, well, George did the hard part for us. Somebody will take the easy part? What you got?
I think it means like well, I'll just read it because I
Mhm.
can't remember. A subclass can define its own unique behavior and still share the same functionalities or behavior of its parent class. So it takes, I think it just takes some
Mhm.
of the features of its parent.
Correct. So it's two different ways that we do this. One is called overriding. The other is called overloading. So overriding is if my parent class has a method named fart, and I have a subclass can also have a method named fart that's different than the superclass. So you can use the same name, different behavior. That's overriding. Overloading is within a class, I can have a method with the same name and a different signature, as in it takes different arguments. Slightly different implementation. So let's say you guys have used methods like this before, that you can give it a string, you can give it a hash, you can give it a couple different things. Oh, okay. But then you need a different implementation to handle those different kinds of things that you got passed. Or I guess you could have some rat's nest of ifs and switches and shit. Or if you have a different signature for it, you could overload the method. So like in Ruby, for example. Rails, Ruby, OP. So if I have some class, actually, I don't know if you can do this, and you might not be able to overload in Ruby. Let's say I have a Java class. And so I have a Java class, and it has a method called, let's see, be a good example. Maybe it has a speak method, and it returns a string, and it takes in a string called words, and it returns, hey, I'm something like that. Now let's say I also have one that takes in an array called words, and it joins them. I have overloaded this operation. These are two completely different methods that have the same name. But you tend to use it kind of like this. You want to accommodate a wide variety of things, but in a strongly typed language, if this is expecting a string, I can't pass it an array. It won't even compile. That's overloading. Overriding, same thing, would be like that, and then I have some subclass, some superclass, and these have different implementations entirely. Polymorphism, those two things. Although they might have to have the same signature. Key part of OOP, polymorphism. Those are two ways that we do it. What questions do you have about old polyam? Yeah.
Can you go back to the second example? I think that was overriding, correct?
Correct. The subclass is overriding the speak method in the superclass.
But why, so why wouldn't you just make it a new, like, method?
Yeah. Like, say woof.
Yeah.
So the reason why is this gives us the flexibility to have some instance equals some subclass dot speak. Works exactly the same as some superclass dot speak. Anything that's like of this type can use the exact same method and let the subclass worry about how it gets done. That's powerful. There's even an equally complicated sounding law about it called Liskov substitution. That says, oh God, I can't stand how people write these things. If S is a subtype of T, then objects of type T may be replaced with objects of type S, i.e. an object of type T. Oh, now it's clear. Fucking assholes. The idea is that, let's say I have some other subclass, like that. Any place that I can use this, I can also use this without breaking the application. That's Liskov substitution. Because I know that they're going to have speak methods. They may implement them differently, but they both have them. That's Liskov substitution. And that's the point of polymorphism.
And then you do dot speak would be with name,
Mhm.
and then I don't know whatever.
Cat.speak is arf baby,
Yeah.
but I'm still dealing with an animal that makes sounds. If I swap one animal that makes sounds for another animal that makes sounds, my app still compiles. It still works. It might not do what I want it to do anymore, but that's the point of this.
Could you give me a programming example of when we use this?
Sure. you might have a user. You got different kinds of users. Every one of those users might have a role. Okay, they might. Let's see, no, that wouldn't be it. What would be a method that would be implemented differently on different users?
Well, I don't know. What if like I'm just spitballing
Mhm.
here, but what if you have like a chat app and we have like the regular users and you have admins,
Mhm.
and when someone sends a message, regular people it's just black text, but when an admin sends a message, it's like red text.
Sure.
Is that like an example of?
But yeah, they might both have. So think of it more like admin chat message and regular user chat message are two different instances. Both of them have display methods. One of them displays it with color, the other one doesn't. But if I swap them out, anything that operates with one of them will operate with either of them. That's polymorphism. Yeah.
In this example, is there any purpose in naming some instance the same thing twice? Like, see if
Oh no,
I'm just
some.
trying to see if-
No, you're. Nope, Friday. Other questions about polymorphism? That's the hard one. What else we got?
I feel like that one relates directly to the third pillar, inheritance.
What's inheritance?
Inheritance is like when a class can inherit certain behaviors from another class.
Mm-hmm. Get state and behavior from other classes. So this is related. The idea with this is that I can go general and then get more specific. I have users, regular users, moderators, admins, but they have some things in common. And rather than repeating all of those across the classes, we can start general, just the things they share, and then get more specific. Okay?
Can you explain more about state?
Yeah. Properties.
Okay.
State and behavior, properties and methods. What else? Anybody come across anything that was critical of inheritance? It's not very popular. A lot of the fathers of OOP, especially James Gosling, the guy who made Java, he got asked once, what's the thing you regret the most about Java? Inheritance is the one that he mentioned. So, reason why is that there's expressions like, all I wanted was a banana, but instead I got a banana, the gorilla, and the whole goddamn jungle along with it. It's very, they're heavy for one, and for two, it is super difficult to come up with that hierarchy and get it right the first time. It'll work, and then we added this new feature and the entire hierarchy falls apart. Or you'll have something that doesn't fall into a neat classification scheme like that, because not everything does. So the alternative is a thing called composition. And anything you can do with inheritance, you can also do with composition. But if I inherit from something, I get everything that it has. If I compose something, I am constructing something from the ground up. So the difference would be, this is Ruby. Let's change the extension back. So I've got this, and it inherits from some superclass. Okay, so there's one way to do that. The other way you would do that in Ruby. Anybody know how you do composition in Ruby? Includes some module. And what's cool about that is you can only inherit from one thing. We include as many modules as we want. So if I had a dog, instead of having dog inherits from mammal, we would do dog includes walkable, includes barkable, includes chewable, includes whatever behaviors I want that dog to have, but I build it out of these little pieces. That's way more flexible than trying to get a hierarchy like this right basically ever. So there's still like some good use cases for this. I think controllers and Rails are a really good example of that. But there's way more bad examples. And so preferring composition to inheritance is usually a good plan. Questions about any of that? Yeah.
When you include walkable, so is that, you say it's a module,
Mhm.
do you define it as a class? Walkable?
No, you define it as a module. So you'd have a module called walkable. And that can have state and behaviors and whatever else. And they get mixed into this like you copy and pasted them. So rather than just repeat a bunch of shit from class to class to class, you can extract it into a module and then just include it in.
And so would you be like requiring files with those modules?
Yeah, you would, well, you do it the way that you do it in Ruby, which is like, you require them in somewhere, or there's a thing called autoloaders, it's include actually, which like if you use it, it looks through file paths for like particular patterns, and if it finds a file that has that name, it'll just require it in automatically. Other questions about inheritance? Yeah, Jerbear.
Can you extend those imports? Can I include chewable and then make my own custom chewable that does more?
Oh yeah, I can absolutely say def chew, which I got in from chewable. I have my own implementation.
And then do you call it super?
Oh yeah, and then if I need, wow, so would super work in this case? It might not. Because when you inherit something, let's say all mammals can chew. If, let's say mammal has a partial implementation of this, I can call that partial implementation with super and say, all right, call the partial implementation here and then do the rest of the implementation. Or you can do it the other way around or something like that. That's in JavaScript also. Other questions about inheritance? Cool, it's the last one. We're not talking about abstraction today. Yeah.
Can you talk a little bit about the module?
Yeah, so it's like a class, except you mix it in rather than inherit from it. That's it.
Each module usually has its own file.
Yeah.
Okay.
So in the interest of time, I'm going to skip abstraction, but let's talk about inheritance. Or sorry, encapsulation. What is encapsulation? It's an important one. Two big ideas in this one. What are they? What you got, Lily? I see wheels turning.
Well, like the binding of data and functions.
Yeah. So that's the biggie. Keeping your state and your behaviors together. Keeping data and the things that work on that data in the same place. State and together and it feels so good. So think about if we didn't keep state and behavior together. If we were just doing regular old procedural programming. I might do something like dog name equals Jeremiah. Dog age equals 5. Okay, well that works. And then I could say like dog bark equals some method that says woof. I'm Jeremiah. This voice sounds like cool. Huh? I don't know, you bullfrog baby? Not anymore. Cool, so this works until I have more than one dog. Now we get, well, how do we solve that if I have more than one dog? Well, like I still need names for these things, right?
Right. Different variable name.
Yeah, so maybe I do dog 1, dog 2. Okay, well this sucks. So instead, I can say what a dog is, and then I can say that every dog can bark, and then we can say when it barks, it console logs woof, I'm, and then this dot name. And then when it gets built, I can pass in a name and an age and say, cool, this dot name is name, this dot age is age. Now I can do stuff like const Jeremiah is new dog Jeremiah 5. Without the ability to do this, we're stuck doing it like this. That's my Samsung grimace. Jesse. Oh, in JavaScript? Yes, that's exactly what we do in JavaScript. And like in functional programming in general. But if we don't have OOP, and we don't have FP, and all we have is procedural programming, we're doing something like this. Oh. That. All right, so that's one part of encapsulation. One more part of encapsulation. Anybody run across it?
No, but is it related to scope?
Not exactly. So the other one is no direct access to state. You can't just get the property of an object. Only way you can do that, either to read it or change it, is through a method. So that's why we write accessors, setters and getters. You can't see the state, you can't change the state. All you have access to is what the object has allowed you to have access to. That's also encapsulation. So these three things are the pillars of OOP. The fourth one's abstraction. Ask me about it another day. But that one's even like debatable if it's not even just kind of covered by all the rest of this. So JavaScript It does all of them kind of poorly. So let's talk about Jesse queued me up pretty well. How we might do something like this in JavaScript is we might make a function called makeDog.
Follow-up question.
Yeah.
So I've heard, like basically a larger function is returning other higher order functions. It's called composition. I've heard it called
Mm-hmm.
before.
Yeah, accurate.
So is that a completely different term relevant to like composition as you just explained it, or is it the same idea?
It is the same idea, very different execution. So if I wanted to do this in JavaScript, I would do something like this, and I could have a this.bark equals some function, and say console.log woof, I'm this.name. And then if I make a dog, I say Jesse is make new make dog Jesse for like that. Just a function call. I use some things that we don't typically do that often. I'm using this, which is just like self, except it's worse. But serves the same kind of purpose. I'm using this new keyword when I invoke the function, but otherwise not so very different. And then, let's see, why is this mad at me? Oh, that's right. That's exactly what's happening.
Doesn't JavaScript, since you get 6, you don't have to make classes like that? You can use class. You can just call a class.
We're getting there. He's just seen this before and doesn't want you to enjoy it.
Typo for this age.
Ah! All right, so I'm such an asshole. So then I do Jesse.bark. And if I run this file, cool. Woof, I'm Jesse. It works. For 20 years, this is how we did like OOP-ish kinds of things in JavaScript until we decided that's a bad idea. So the more functional way to handle that would be to make a bark function that takes in a dog, and then you do something like I'm dog.name. And so then I make a dog like that, and then I call bark with the dog. So if I do that, I get woof, I'm Jared. So to recap, old way of doing this in JS, OOJS, the functional way of doing that exact same thing, the new way of doing this in OOJS, class, make dog, except use a capital letter. Then make a constructor for it. Constructor is just like initialize, except constructor is the word that every other language uses. And then we make our bark method, except we don't have to use this there. this looks like that. Cool. So now if I say const Ahmed equals new, actually we'll just call it dog. And pass in Ahmed and Ahmed dot bark. I run all this. Cool. 3 ways of accomplishing the exact same thing. So we'll say new OOJS, old OOJS, functional JS. Anybody spot the big difference between the functional approach and the OO approach? It's huge. It's one of these like one of these pillars we just talked about. It's doing the opposite of it. Aaron. It's not encapsulating. What's it doing instead? It's keeping the data and the behaviors completely separate. That's the big functional idea. Putting them together in one place, object-oriented. Keeping them night and day separate, functional idea. So, if you're ready to have your mind blown, this old OO way and this new OO way are not just like functionally the same. This is actually just some syntax on top of this. It's doing the exact same thing. JavaScript is not an object-oriented language. It doesn't have a lot of the things that we would need to do. I can't, Damon burned like 3 days once trying to get that like add at all kind of idea to work where like you're shoveling a new instances in. You can't do it. It's like fundamentally not a part of this language. But we can kind of make it look that way with very familiar syntax. So the reason this came out is that there are people who are coming from Ruby and Java and whatever else as JavaScript was getting more popular, and this makes them feel more comfortable than that does. Ta-da.
So, this is a very opinionated question, but is the heat that OOP gets from functional people mainly due to the fact that a lot of servers are like are built using OOP, like Java, like Ruby? I don't know about Python or PHP.
No, the heat for OOP in general comes back down to this. So Chisi was right. It's way easier to talk about applications in terms of like metaphors and objects and things that we relate to. The problem, the reason like why we wouldn't just do this all the time is it's not very accurate and it's hard to get right. And so as a program grows in complexity, you like increase the chances that this just ends up being a lie. You end up using words to represent things that aren't actually what they do. Your metaphors start falling apart. If you start talking about these mathematical relationships, way lower likelihood of that happening. And so a functional program tends to be a lot more bulletproof than the equivalent thing in OOP.
Is there some sort of hybrid or like another type of?
Yes, there is. That's JavaScript. Because JavaScript isn't a functional language either. It's neither, but it can kind of do little bits of both. And that is like, that's a pretty goddamn nice programming experience, being able to just slip in and out of paradigms. Because in Ruby, you can't, like everything is an object. That's not the case in JavaScript. JavaScript has primitive values. There is nothing in Java that isn't a class. In a functional language, there are no if statements. There are no loops. There are no variables. Well, they're variables. It's very difficult to make them because they're state. We want to keep the state out of our behavior. Why would you put state inside of a function? So JavaScript, we can just a little bit of this, a little bit of this, a little bit of this. And it's not like you miss some of like the magic of having a pure paradigm, but it's really nice. Like even in one file to be able to do like these two things. I think it's cool. Jesse.
So is prototype-based language, like is that not a paradigm?
No, it's a style of object-oriented. So what Jesse's talking about is that JavaScript doesn't have class-based inheritance, which is why like this irritates me so much. They aren't classes. When you make a class in Ruby or subclass, this is the superclass. This is the subclass. The subclass is also the superclass. It's all of these things together as one thing. If I make a new subclass, I also made a new instance of the superclass. So we'll call this classical inheritance. It's not classical like, it's a classical as in like class-based. So that's classical inheritance. JavaScript uses a thing called prototypal, not prototypical, prototypal inheritance, which works like this. If I look up a method or a property on a subclass and it doesn't have it, it looks at its superclass and goes, cool, do you have it? But these are completely independent objects. It's a minor and like mostly like not important distinction because you end up using them in very similar ways. But it ends up being super confusing if you're from a classical world. There's some things that just don't behave the same way when we're doing this because these aren't actually classes. They're prototypes like this. Cool. More questions before I show you like the 3 things you're going to need to learn about classes in JavaScript. Jer Bear.
Can you do static methods with the prototypes?
Yes. So the way that you would do that, so what's a static method? Who knows? We did them in Ruby. We used a different word for it. I'll give you a hint. Add all was one of them. Or the way that we accessed add all was one of them. Class methods. Class methods, that's a Ruby thing. Static methods is what every other language calls it. So the way you would do a static method is with make dog, like this function definition. You just put the thing on it like that. Like that. Because functions are what? They're just types of objects. So they have properties. We can assign them whenever we want to. That's how you do a static method.
You have to do it outside.
You have to do it outside. That's like another thing that like it's just not what it's fucking for. So we got some new syntax in the new version of this. We go static all. It ends up doing the same thing. Cool. What else?
Yeah, when we're talking about this dichotomy between OOP languages and functional languages, is it a good idea when you're like making a project or something to like have languages that complement each other well? Like if you don't know how your program's going to scale, does it make sense if you're really dependent on one functional language to like have it? Does that kind of make sense what I'm getting at?
I think so. I would think of this less like wine pairings.
Okay.
and more like, what is the problem that you're solving? So, if I think about what functional is the best at, it's data transformations. Anything that's like easy to represent as start from here, end up here, how does it get transformed along the way? That's where functional shines. If I'm dealing with something that is lends itself way better to metaphors, I'll give you like a good example of that would be active record. ORMs, you can do those functionally, but it sucks. I'm like, well, this has many of these, and it has an all method that gives me every one of them. The functional equivalent of that kind of sucks. So you can go, okay, well, what does my project need more of? What would it benefit from having more of?
So would you say it's primarily an issue of scale? Like, I don't know, if I picture something like fucking Amazon.com,
Mhm.
right? When they first started, I imagine like some of what they did was kind of like straightforward.
Mhm.
Like, but I imagine as it grows, the algorithms get more and more complex, and so like they probably have to start hiring more mathematicians and stuff.
No, like yeah, but I mean, Facebook is still essentially PHP. Zuck writes some PHP in his dorm room, and now it's Facebook. So, like, what they did to accommodate that, like, no sane person would choose PHP to write Facebook now, is a lot of their engineers were contributors to PHP. It's open source. And in fact, this is like such a weird part of programming history, but so it's an open source project. A lot of open source projects have maintainers that are companies. They're usually consultancies for whatever the technology is. So once upon a time, Node was a wide open source project, but it was like the people approving the pull requests was a company called Joyent. And Joyent was a Node consultancy. So you want to make a change to Node, you issue a PR, Joyent reviews it, merges it in. PHP, that was, still is, Zend. Zend is a PHP consultancy. You want to make a change to PHP, you're welcome to. They're the ones who have to approve it. So in the case of Node, Joyent was slow and dictatorial and incompetent. And it's an open source project, so they forked it. The rest of the community went, you know what? Fuck you. We'll manage Node ourselves. They make a fork of the project. It was called IOJS, and I thought that was the end of Node, like for sure, because they just fractured the community in half. And IOJS like immediately got a ton of cool features that Joyent had been blocking forever, and then like Joyent kept working on Node. It's like, oh, holy crap. So Joyent came to their senses and realized that a house divided against itself cannot stand, and proposed the creation of the Node Foundation, of which Joyent is still a member, but they got Microsoft and some of the open source maintainers and a couple people to essentially have a committee, and that's who runs Node now. So Node starts as one thing, forks, and like this does not happen very often in programming, got back together again. This is like, it's a pretty accurate metaphor. Mom and dad got divorced and then remarried. Like, it's not never happening, but like, it's unusual. So now let's now we think Facebook and Zend. Facebook and a consultancy that maybe at most had 20 people working for it. Facebook needs to do all these things. Pull request, pull request, pull request, pull request. And like the one guy whose job it was to like look at the just avalanched. So Facebook forked PHP. So now it's called Hack. It's also open source. But as far as I know, Facebook is the only company that uses Hack. I would say though that even with all of those things, they wouldn't do it in PHP today. They had to fork it. I have all these engineers working on it. I think that's like their last problem. Okay. And so picking the wrong language or whatever is not that big a deal.
Okay, thanks.
So when, because Node is open source
Mhm.
and when it broke off, is that when V8 was created?
Nope. V8, that was always in there. V8 is part of Chrome. And so when Ryan Dahl originally made Node, he just yanked that part out of Chrome, or Chromium, more likely, and
Brought it to Node.
brought that to Node. That was in there from day one. Cool. So like we're at feelings, but I do want to show you like I don't what the fuck we ended up talking about in this. Whatever. I'm sorry. I'm sorry. Let's talk about like the 3 things that you probably need to know about classes in JavaScript. So use the class keyword. If you need to inherit from something, extends, not the shovel thing. So we'll say some superclass. It's capital letters or Pascal case by convention. It's not a requirement. You could make it snake case if you wanted to, if you want to get punched in the face. But otherwise, it's Pascal case. The thing that people fuck up the most on this is not a JavaScript object. So these aren't like keys and values and stuff. You can assign some property equals like that. You can make methods by going some method. You actually got a couple options here. This is the special syntax they made just for this, which nobody can use. So the preferred method, and what you'll do like all throughout React, is you'll do fat arrows instead. There's a couple built-in magical things. The only one you need to worry about is called constructor. When you do new sum class, this is the function that gets called. It's exactly like initialize was in Ruby. Sum variable. And just like in Ruby, this dot sum variable or sum property, I'll say sum variable, equals sum variable, works the same way. And Jeremiah had mentioned earlier, like super. If I need to call the constructor of the superclass, you can call it there, you can call it there, and do whatever you want. And then, let's see, what else do you need to know? Jesse, can you think of anything else that like needs to be in there for React?
I guess export default isn't technically part of this.
No.
But export
So yeah, if I want the thing in this file, I want to make this class in this file. I want other classes to be able to import it. Put export default in front of that. And now this is some class.js. And now I make another file called index.js. And I want to use this class. So what I do is I import some class from some class. And now I can do some instance equals new some class, and then whatever I was passing into that constructor. That's it.
Do you have to set it to a variable once you import it into that class?
Yeah, so the import, this is another thing people mess up about this a lot. This isn't really a variable. This is like a very particular syntax. But it is not a requirement that like you use whatever the thing is. So for example, you'll see these occasionally that are just like this. And the mere fact that you imported it, like, it has some side effect, it activates that file, it does whatever. That's less common, and it's not what you'll do in React. React is just kind of like this. Yep.
Maybe I heard you wrong, but they said that in JavaScript you don't actually
Yeah, kinda, but it's a mostly academic distinction. If I have a subclass in a classical language and I call some property that actually exists on the superclass, all right, cool. It's there, it's all one thing. If I do this in a prototypal language and I call something that exists on the superclass here, it doesn't exist. So it goes, cool, does my prototype have it? Ends up working the same way. One of the big differences, though, is like, and fuck, end of the day on Friday. This can change at runtime. Like while the application is running, something's prototype can change. Something's superclass can never change.
Does that change the subclasses as well? If that super changes at runtime?
No, you go. It just gives you the power to do something like, I want a different prototype for this. Point it somewhere else. It's a pattern that you can't do in classical inheritance. Cool. What else? One of the reasons that I think that classes in JavaScript are so broken, why React is getting rid of them. I've actually started asking around like when we can stop teaching React with classes. The reason that like I'm so opposed to this is this. This in JavaScript was never intended to be used this way. So let's do an example. So I have some method and I console log first this. All right? Neat. Now I'm going to have some other method. Second, this. I'm going to have yet another method. Third, this. All right. All right, so I have this class here. That's legit. All right. Oh, I do. Cool, so I make some instance as a new some class, and I call, let's do it this way. Some method calls this dot some other method. Some other method calls this dot yet another method. So in Ruby, this works exactly the way you'd think. Let's see, first, second, third, and this is the same thing each time. If I call some instance dot some method here, wonder what happens. Oops. Node some class. Oops. It was blank each time. Shouldn't have been. So the problem, what I wrote at the end of the day, the problem is that in JavaScript, this is based on the calling context, which is like the context where the function was invoked. Here, it's the class. Here, it's actually also the class, because some methods calling context is the overall class. But on the third one, it's not. The context on the third one is the second method's function body. This is dumb. If these were fat arrow functions, none of this matters. This context never changes if it's fat arrows. So that's why we have you do that in React. Ta-da! Questions?
If we feel like not incredibly comfortable with this right now, do you think that like should?
No, like you'll be fine.
Okay.
I don't care if any of you can do anything with this stuff. This is like big ideas at this point, and if you can write a method and assign a property into class in JavaScript, you are fine in React. And if you're not, you'll learn it in 10 minutes.
Okay.
Cool. Anything else? Let's tidy up.